So I'm going to pick up where I left off last lecture on Friday. I was talking about inheritance then, and you guys asked a lot of questions about casting and stuff like that, and hopefully this part will answer a lot of those questions. So, number one, suppose that we have a new method in the tail list class. Remember that tail list is a subclass of slist, and that new method is called eatlist. Now remember, I defined this in the tail list class, so there's no eatlist in the slist class, because parents don't inherit from their children. So I could write, for instance, tail list t equals new tail list. So t points to a tail list, and then I can call the eatlist method on t. And that works just fine, as you would expect it to. But what if I declare an slist, S, and make it point to a new tail list? So now the static type is slist, the dynamic type is tail list. So since the dynamic type is tail list, we have a tail list object. We should be able to call eatlist on it, right? So let's try it, s.eatlist. And this does not work. The compiler throws a hissy fit. And so why? Why doesn't this compile? The reason is that S is static type slist. Java compiles code one line at a time. So when it gets to this line, it's forgotten this line. All it knows is that S is an slist. It has no idea what S might point to, though. It could point to any type of slist object. And not every slist object has an eatlist method. Now, there are some slists that have eatlist methods. They're called tail lists. But not every slist has an eatlist method. So Java cannot use dynamic method lookup on the variable S. Now, if I had defined eatlist in slist instead, then this last line would compile fine. But I didn't. I defined it in tail list, and so not every slist has an eatlist method. Questions about that? Yeah. Uh-huh. In that particular case, yes. So if the slist class had an eatlist method and the tail list class had a different eatlist method with the same prototype, then this line of code would compile fine because every slist has an eatlist, and it would actually call the eatlist method in the tail list class because that's the dynamic type that S is pointing to right now. Number two, I pointed out earlier that you can't assign an slist object to a tail list variable. The rules are more complicated when you assign from one variable to another directly rather than just creating an object. So let's see what happens if you say you have an slist variable and you have a tail list variable and you want to assign back and forth between them. And the thing you're assigning back and forth is a tail list. So I've got a tail list object. I can assign it to T because T is tail list. Every tail list is an S list, so I can assign it to S as well. And I can do that indirectly. I can say S equals T, and Java looks and says T's static type is tail list, S's static type is S list, every tail list is an S list, so this assignment works fine. That's good. But if I try to go the other way, I have a problem. I have a compile time error. So why should that be the case? S is pointing at a tail list object. I should be able to assign a tail list object to a tail list variable, shouldn't I? But at compile time, Java just compiles one line at a time, and it doesn't remember what S is pointing at now. It will not know that until runtime. So right now it just sees that you're taking an object that could be any S list, and you're trying to assign it to a tail list variable. Well, not every S list is a tail list, so Java won't let you do that. At least not directly, but you can do it with a little persuasion. See, this is a lot like assigning a double to a float, assigning a float to a, this is like assigning a float to a double. This is assigning a double to a float. Java's afraid of, losing something, like the methods in the tail list class, in this case, the extra precision in the case of doubles. So what it needs is a little persuasion in the form of a cast. T equals tail list S, and that's good. That will compile and work and run. See, Java's a little bit like a jealous lover. It just needs a little bit of reassurance. It's okay, baby. It's okay, Java. I promise that S is really a tail list. You can count on me, Java baby. I'm going to take you to the end of the rainbow. End of the rainbow, you and I.
Sound very practiced.
Well, I know that a lot of you are wondering right now, what happens when Java finds out that I'm a lying cheat? Let's find out. Let's set S equal to a new S list. It's not really a tail list, but I'm going to tell Java it's a tail list anyway. So I'm a big liar, but Java will compile that line of code for the exact same reason it will compile this line of code. Java's a sweetie, it trusts me. But its trust was misplaced, and it will find out at runtime. Because at runtime, S will point to an S list, dynamic type, and when that happens, Java actually checks whether I told the truth or not at runtime. When I try to assign whatever S is pointing at to T, it checks and it sees, oh my God, it's not a tail list after all. He was lying. And so you get a runtime error. But not a compile time error. By the time Java finds out, it's too late and I'm on to the next compiler. All right. Sometimes you can use these casts directly within a line of code as well, and it can be really handy at times. Like, for instance, you'll recall that your linked lists store objects. So you can pull an object out of a linked list with something like, I don't know, the nth command, which returns type object. So you say int x equals, here's what doesn't work, by the way. T is my tail list. I extract the first item in the list. It's an object. Suppose that that object is an integer object, which you've encountered, I think, in a recent, was it homework or lab? I forget which. But anyway, when you've got an integer object, you can get the integer value out of it with the int value method. But there is a problem here. You see, nth returns an object, and int value is not defined on all objects. Int value is defined on integers specifically. So this is a compile time error. Not every object is an integer object. And so the smoothest way to get this to work without having to change this into two-line codes and define an extra variable is to stick a cast right in the middle of things like this. I have a big bracket even before the cast. So I'm casting to an integer object t.nth1. And I have to put all of that inside parentheses before I call the int value method. But now I can call the int value method because Java is persuaded that this object I'm getting out of the list is actually an integer object, and now I can use it the way it was meant to be used. The reason why I need this parenthesis here and this parenthesis here is because this dot operator binds more tightly than a cast. If you don't include those parentheses, Java will try to execute the dot first and the cast second, and then you'll get the same compile time error you had here. So you've got to tell it, do the cast first, and then the dot operator. And this works. Now, some methods are defined on every object, every single object, so you don't always have to cast things. Like if you want to call the toString method, well, every object has a toString method. So in that case, I can just go t.nth.toString, and et voila, that works. Question?
If you've overridden the toString method, do you have to cast it to use the overridden version of the method, or will it?
Absolutely not. So the question was, if you've overridden the toString method, do you have to cast it? And the answer is, not only do you not have to cast it, but casting is futile and will have no effect on what Java actually does. Because what Java will do is dynamic method lookup. And the thing you should know about casts is all a cast does, maybe I should put this on the board, casts change the static type of an expression. But when you call a method, Java uses dynamic method lookup and only looks at the dynamic type. So changing the static type of something does not affect which implementation of the method gets called at all. It only affects whether or not you can call a method at all. Other question? Yes. Oh, gee. Well, my notes actually say string, but I guess I was in a hurry. You are right. Thank you for pointing that out. So, in the back, please. Uh-huh. Is there a what before that line? Oh, is there a permanent change to the static type? No. S still has the static type slist, and it will have the static type slist forever. What has a static type of tail list is the expression. So this expression here, as a compound object that Java computes, is an expression with static type tail list. And therefore, you can call tail list methods on it. So cast change the static type of an expression, not the original variable. Other questions about this? All right. Third thing you should know is that you can it's very useful sometimes to be able to figure out what type of an object is directly. So you can use an if statement and treat different objects in different ways. Like, if you have a list of objects and there's a bunch of different types of objects in there, you might want to treat different objects in different ways without having to go all to dynamic method overriding to do that. So instead, you can just say, use the instance of operator. And that tells you the dynamic type of an object. At least within modulo inheritance. And warning here, that is a small lowercase letter o. Every semester, there's someone who types an instance of with a capital O, which seems like the right thing to do, because that's the usual rules, but they broke the rules for instance of, so try to just remember that that's a lowercase o. And then, of course, you get a compiler error if you use an uppercase o, and it doesn't tell you what you did wrong. And here's how it works. You say something like, if instance of tail list, then it's safe to attempt to do the cast. Now, one thing is, this does not necessarily mean that S was declared to be a tail list. S could have been declared to be a subclass of tail list, and this will still be true. So this is false if S is null or doesn't reference a tail list or subclass of tail list. So subclasses of tail lists are tail lists. Questions about that? Yes? No. No, instance of is not a method. It's a built-in Java keyword, so there's no dot. Java has an interface keyword, which is confusing because I've already taught you about something called interfaces. And that word interface is a general computer science term, and that's how it's used in all kinds of different languages. Question? Uh-huh. Well, just because I've said if S is instance of tail list doesn't mean that the compiler will remember that by the time I get to this line. You know, the compiler compiles this line dutifully, then forgets about it, and then goes on and compiles this line. And so I still have to reassure the compiler every single time that S really is a tail list. Because the static type of S is S list, and that doesn't change. So the confusing thing about Java interfaces is that the interface keyword is not the same thing as the interfaces I've taught you about, although it's related. So in this class, I will try to use the word just plain interfaces when I'm talking about the public method prototypes of a class and the behaviors of those methods. So the same definition we've been using so far. When I'm talking about the interface keyword in Java, I'll say Java interfaces. So interfaces equals the same thing they did before. Public method prototypes and the behaviors of those methods. Public fields too, though those don't come up as often. Java interfaces will henceforth refer to Java's interface keyword. What is a Java interface? Okay, I'm on the wrong page. So, put that on the stack for now. I was supposed to teach this side of the paper first. We will learn about abstract classes first, and then we will go back to Java interfaces, which are like abstract classes. Hey, those Java interfaces are so uncool. Let's talk about abstract classes instead. An abstract class is a class whose sole purpose is to be extended. Why would we want that? Well, sometimes you want a class that defines an abstract data type but doesn't actually have an implementation of that abstract data type. Like, for instance, lists. I'm going to declare a class of lists, but I'm not actually going to have a complete implementation of lists. I'm just going to make this be the list master class, and then I'm going to have 100 different types of lists that are subclasses of the list abstract class. And so I'm going to decide that, well, every kind of list, no matter how it's implemented, should have a size field. I'm just going to decide that. And every single list, no matter how it's implemented, should have a length method that allows all users of all kinds of lists to figure out how long their lists are. Seems reasonable, right? I'm even going to provide an implementation of that for all the lists to use, although they can override it if they have a better implementation. I'm also going to have, and here's one of the more interesting things about abstract classes, I'm going to have a prototype that I say every single list, or every single working list class or subclass of list must have a method called insertFront, and it has to have this particular prototype. Well, almost this prototype. Anyone who implements a subclass of list must provide a method called insertFront that takes an item and returns void. But I'm not going to implement it. This is an abstract method. I'm not going to provide an implementation. I'm just going to dictate that every subclass must have an implementation. And it's up to them to work out how to do it. And in practice, you'd want to add more of these, but this will do for now. So now that we've got this abstract class, what can we do with it? Well, what we cannot do with it is we cannot create a list object. You can't do that directly. But you can declare a variable of type list. So maybe in some other method, you find this code, list mylist. Even though there is no such thing as a list object, you can declare variables whose static type is list, and that can later be used to point to subclasses of list. So that line works fine. But if I actually try to create a list object, like that, well, lists are an abstract class, which means there are no such things as list objects. So this just gives you a compile time error. Sorry, no such thing as list objects exist. Now, abstract classes can be extended in the same way as ordinary classes, and those classes are not usually abstract. They can be, but usually I would extend this with an S list or a D list or something like that. Question?
Now, what's the point of having this public abstract void insert file? It doesn't have any actual code. The method doesn't actually exist.
This here?
Rewrite that method for every extended class.
That's right. I'm going to have to rewrite that method for every class. There are 2 points of having this here. One is that it forces every subclass that's not abstract to have this method. So I cannot write... pardon?
How does it?
Well, the compiler won't let you compile dlist extends list unless dlist has an implementation of insert front with exactly that prototype, minus the word abstract. The second reason to have this is so that I can say mylist.insertFront without... And so this guarantees that every list has an insertFront method. So now I can call insertFront on every kind of list. So if I want to write a list sorter that uses the insertFront method, I can do it, and it will sort every kind of list. So one of the defining things of abstract classes is that they lack an implementation, abstract methods. Abstract methods, like insertFront, lack an implementation. That's what So now I'm going to give you an example. We're going to create an S-list class. That extends the list class. The S-list class inherits the size field. So I don't have to declare that again. That's already there. It inherits the length method. And since there's an implementation of the length method up there, I don't have to supply another one. I can if I want to. I can override it. But right now, that length method is good enough for S-list. I have to provide an implementation of insertFront, though, because there isn't an implementation over there, and there is a prototype. And that says, if I want to have a subclass of list that's not abstract, then it has to have an implementation of insertFront. And since this is a real implementation, I'm actually going to write code. I do not have the word abstract over here. And the implementation is pretty simple. You just need to add a new node to the list and update the size field. So there's a good start. Yeah. Define what? Head. Oh, did I? Yeah, I skipped that line, didn't I? Thank you. I'm going to add a little more code to the bottom of this much later, so you might want to leave a little space here. Question? I don't have any reason to need a declaration of head in the abstract class. If I wanted to, I could, but I can think of some kinds of really fancy lists that wouldn't have heads. They'd have something else. So space, 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 I guess. Some rules. A non-abstract class may never, so any class that doesn't have the abstract keyword in front of it, may never contain an abstract method nor may it inherit one without providing an implementation. Them's the rules. So now that I've declared this class, here's what I can do. I can not only declare a list variable, but I can also assign it any subclass of list as long as it's a concrete class that I can actually make objects out of. SList is a subclass of list, and SList is not abstract, so this line works. And I can even call insert front on my list. I don't have to do a cast. I don't have to know what the dynamic type of my list is. This will not only work on SList, it'll work on all of the other 100 non-abstract subclasses of list as well. So again, I said this earlier, but now that I've written it on the board, let me say again, the reason why you would want to put an abstract method up here is so that you can call insert front on every kind of list without knowing what kind of list it is. So if you write a list sorter that uses insert front to sort lists, it'll work on all the different types of lists, not just one. Question? You cannot? Okay. Well, there's an example over there. If here is an abstract method, insert front. Here is a class that is not abstract that inherits that abstract method. So this inherits insert front, well, it inherits the prototype, but there's no implementation over there. So I have to provide an implementation, which is what I did. And if I didn't provide an implementation, if I just erase these 4 lines and try to compile this, I'll get a compile time error. The compiler will tell me, nope, you cannot compile SList until you give me an insert front method implementation. Yes, sir? Yes. If 2 signatures match, then you have to return the same return value. Otherwise, there's a compiler error for that. Because you promised up here that you're returning void. If you try to return an int over here, Java's going to say, no, no, you lied. Other questions? Yes? Yes, an abstract class can extend an abstract class. And if you do that, then you don't have to implement insert front yet. Maybe in the next class down. Any other questions before I go on? Okay, let's get back to the question of what an abstract class is good for. I've said it again already, but I want to formalize it a little more. First of all, I want to point out something, that this list class doesn't have a complete implementation, and yet it is still an abstract data type. This whole thing is an abstract data type. Well, when you throw in the behaviors. Why is it an abstract data type? Because there is a complete description of the interface between the list class and the external world and how those methods are supposed to behave. And the implementation details are hidden, so you can implement 100 different kinds of lists, implemented 100 different ways, and they'll all seem to behave the same way from the outside to a user. And a big part of the point I wanted to make is that if you implement a list sorter or any other algorithm that uses lists, then one list sorter that sticks to the interface, like doesn't try to be an evil tamperer and look inside the data structure, but just uses the official behaviors of the interface, then that list sorter can sort every kind of list, including lists that you haven't even imagined yet, that haven't been implemented yet, that will be implemented a year from now. And the way you do that is you write a list sort method that takes in a parameter of type list and then does its stuff by calling methods that all lists have, like insert front and length. So in another part of the universe, your project partners or your coworkers at your company can implement all different kinds of lists without even telling you about them. And so you can have hundreds of subclasses of list. So there's the kinds we've already seen. We can have S lists and D lists and tail lists. But you can also imagine a lot of special purpose lists for special kinds of procedures. Like you might have what's called a timed list. The purpose of a timed list is to record the amount of time spent doing list operations. That way you can do timing studies of your list sorter and all your other code that uses lists. You could also have a transaction list. What is the purpose of a transaction list? An example of a transaction is whenever you go to an ATM and take out money, that ATM machine is doing transactions with some central database that knows how much money you have. Now, if the power happens to go out while you're doing that transaction, it is deeply in the bank's interest to make sure that the power outage does not cause them to forget whether or not they gave you money. And so database transactions often care a lot about logging all the changes on a disk in case there's a power outage. So that billion-dollar drug money transfer you make to Switzerland doesn't get lost. And, you know, there's 2 points to this. One point is that the list sorter, I want you to sort of imagine a 3-level hierarchy of modules, each of them independent. There's going to be one more on top, so leave room on top for the third box. At the bottom, you have your list abstract data type, which is defined to act a certain way. You know what insert front is going to do, even if you don't know how it's implemented. On top of that, you can write methods that manipulate lists in interesting and useful ways, like a list sorter that sorts every kind of list and calls the methods in the list ADT. And on top of that, you can have an application like your ATM machine or your air traffic control console or whatever. And what's interesting about this, when the application calls the list sorter, is that it's the application and not the list sorter that chooses what kind of list it wants to use. And so that is the magic of this. This is the call by which the application calls the list sorter. When it calls the list sorter, it passes in a list. List is an abstract class, so you don't even know what that means. But I can write a list sorter, and 5 years later, you can write a new kind of list and an application that use my old list sorter, even though the kind of list I'm using and the application weren't even conceived of when I wrote the list sorter. And the application gets to pick what kind of list it wants to use. So that's why you would want to use an abstract class. Question here.
Yeah, the list sorter, for example, like, it has to be a method inside of a class, but it takes a list as an argument. So, like, what kind of class would you put this list sorter in? Would it be a class of its own?
I would put the list sorter in a class of its own, yes. I just name it list sorter and
All it does is sort lists.
yeah, and you might never create list sorter objects. It might just be all static methods, maybe. Yeah. It might only have one method in it, the sort method, for all you know. Yes? The list sorter is restricted to only using the public methods and fields of the list class. So if you left some functionality out of your list upper class, so there's not enough functionality to write a list sorter, you're obviously in trouble. So there is obviously a trade-off here. On the one hand, I get the flexibility to sort lots of different kinds of lists, including lists I've never even conceived of. But if I forget to add some important method to the original list description, then that might limit my flexibility in the future, once all those lists have been written. Now, sometimes you'll have lists that have special methods that are only used by that list. Like a timed list would have special methods you call to find out how much time everything took. And that would be okay, because your timing application would only use timed lists, and it would know how to call those extra methods that you declared in the subclass. That's okay. Question? In the list class, well, what was the question again? Well, we do have a method that calls insert front, although it's abstract. Do you mean, can we have an implementation? Can we have it in list, not a subclass? Well, if you want to put an implementation here, absolutely you can. That's what I did with length, right? Length has an implementation, so. Other questions? Yes? If you leave the word abstract in where? Uh-huh. Can you still... Over there? No, if you declare a method abstract, then you can't implement it. You just put a semicolon there. If you want an implementation here, don't declare it abstract. Yes, in the back. Well, MyList, let's see, which MyList are we talking about? This one right here? MyList is a variable with static type list that points to an object. Sorry, MyList. MyList is a variable of static type list that points to an object that is an S-list object, and therefore the dynamic type of my list right now is S-list, although that could change. All right, back to where we can pop this off the stack now. Java interfaces. A Java interface is like an abstract class, only different. And there are two differences. Here's the good difference. A class can inherit from only one class in Java. In other words, for those of you who have heard of multiple inheritance, Java does not have multiple inheritance. But you can implement any number of Java interfaces. And by implement, I mean the implement keyword, which is another way of saying inherits. Okay. So you can think of this as a very limited form of multiple inheritance. You can't inherit from multiple classes, but you can inherit from multiple Java interfaces. Unfortunately, Java interfaces are crippled, and so here's the bad news. A Java interface cannot do several things that an abstract class can do. It cannot implement any methods at all. So no length implementation, nor can it include any fields. With one exception, they do allow static final constants. So in other words, what's left over? Well, it only contains method prototypes and constants. What is going on here? Why do we have abstract classes and then Java interfaces, and one has advantages and the other has different advantages, and why not just make them all one thing? Well, the reason is something that you might understand if you take, what is it, CS164, the compiler's class here. The basic problem is that multiple inheritance is hard to do in languages. And languages like C++ that do multiple inheritance have issues that come up, like what if your class has two different superclasses and both superclasses have a field called size, except each of them does something completely different? Now when you refer to size, are you referring to the size you inherited from your mom or the size you inherited from your dad? That's not the only problem of multiple inheritance. There are trickier compiler issues that you can't understand until you actually know how to implement compilers. But the Java designers took the easy way out and did a weak form of multiple inheritance that avoids most of the problems, both in the language definition and in the implementation. So that's what we've got. And it's not necessarily my favorite design, but there you go. Question? Abstract classes can inherit from other abstract classes, yes. So, where are we? What's that? Can they inherit from non-abstract classes? No, abstract classes cannot inherit from non-abstract classes. So I just want to say that since I ran a little short on time last time, there's a little bit of lecture notes on interfaces left that I can't go through today. It's easy stuff, but everything up to the end of the lecture notes today is what's possibly may appear on the midterm. And the midterm is 1 week from today, next Monday. It will be right here in this room, in class, from 4 to 5. And so if you're wondering what to study, everything up to the end of today's lecture notes, including the stuff I just didn't lecture on. The stuff I cover Wednesday and Friday is not on the first midterm.